All right, so if you're listening to this tutorial, you would have seen on the event page that there was a link to where you can install Python. And this here is the page. So I'd recommend installing Python 3.7, and then you can choose the version for your operating system. So once you've got that installed and open up Anaconda Navigator, you'll get to a page that looks something like this. And from here, there's a whole heap of different environments in which you can program in Python. So some that I've used before and are quite popular, we've got Jupyter Notebook, PyCharm, and Spider. So for this tutorial, I'll be using Spider. Let's jump straight in. All right, so first of all, comments are written by writing a asterisk, and then everything on that line after the asterisk is a comment. So what that means is that Python doesn't actually parse this code when it comes to run. Comments are only there for you to read. So it basically gets skipped by Python. So every programming language has its own syntax, which describes how code must be written. And you can think of it a bit like the laws and rules behind the English language. If the rules aren't followed, then we don't understand. And the same applies to code in Python. While it's not mandatory, it's a good habit if you can write your code with a consistent style. So it doesn't affect the output of your code, but it makes it more readable to yourself coming back later and to other people. And if you have a smart IDE, so what the IDE is basically this whole page, which is where you can interact with Python. So Python itself isn't really a program. Isn't really a program that you can interact with. It's kind of like the skeleton. And then the IDE is pretty much what you see on the outside, so like the skin. So if you have a smart IDE, it will enforce and suggest good style practices. So the IDE that I'm using today is not that great at it, but it's better suited as like an introductory tool. So some examples that I followed in this file is keeping each line to a maximum of 120 characters. So quite often you'll find that 120 characters is larger than standard. Let me just 120 characters is larger than typical, but for all the comments in this file, I'm just using that. Another thing I've done is put spaces between all of the operators. All right, so just a quick rundown of this particular IDE. So there are buttons across the top, these ones here, which mainly which run your code, and you can interact with the kernel. So this one here, F5, will run the whole file. This one here will run a selection or a line. And then these ones here are used for debugging. And debugging is very important, particularly as your programs get longer. Debugging is basically what we call, it describes how we find problems in the code and fix it. So these tools let you step through line by line or step out and into particular functions as you need to. I won't be using them today, but you will definitely need them if you do some more advanced Python programming. All right, so we'll start off by just talking about data types. So Python uses data types to represent different styles of data. There are many inbuilt data types, but users can also define their own. All data types are stored as bits at the end of the day in the machine, either zeros or ones. And to convert between human readable format and the bits, some kind of encoding scheme is used. Now, you don't need to worry about the details of this, but it is good to be aware of it. And it's a very common encoding scheme for strings, which is basically text, are ASCII tables. So some very basic data types in Python are integers. So these are just whole numbers ranging from right down towards negative infinity up towards positive infinity. Floating point numbers, which are all decimal numbers. We have Booleans. So these are either true or false. And when these are converted to bits, they will show up as either 1 for being true or 0 for being false. And then we have strings, which is basically text. So any character or number can be a string. That's important to bear in mind. So numbers can be strings. Basically, anything that's that start and finishes with an apostrophe, the same apostrophe, is a string. So we can perform operations of data types using mathematical and other operations. So let's have a look at some really basic operations where Python can basically be used as a calculator. So let's say we wish to add two integers, 5 plus 2. Now I'm just going to run this single line using F9. It means the output here is 7. So subtraction, subtract two floats. Now we get 7.79. Now it may look as though something went wrong because there's a whole series of trailing 9s, but you have to bear in mind that exactly be represented on computers. They're only an approximation can be represented. So this is basically the approximation of 0.79, but you don't need to worry about that too much. So we can do multiplication and raise something to an exponent. So it's important to note here that the 2 asterisks are used for that and not a hat, which is common in many other programming languages and like Microsoft Word, for example. So yep, 2 to the power of 3 is 8. We can divide two integers, just like this. And note here that even though we have integer inputs, we get a floating point output. So the output doesn't always match the same type as the input. Now, if we were to use 2 backslashes, forward slashes for division, it actually truncates all decimal places. So this is not the same as rounding. It literally discards everything after the decimal point. The rules associated with mathematical operations. So first the power will be done, and then the multiplications, and then the addition. So you can also use brackets to enforce any kind of order of operations that you need. So -4 - 3 -7, and then a quarter of that, and the reciprocal is 1.75. So we can also see that some numbers are represented in scientific notation if they're either very large or very small, and Python uses E and then either a plus or minus, and then the exponent to represent that. Whereas E is basically multiplying it by is base 10. So operators don't just work on floats and integers. They can also be applied to strings, and you might find some interesting results when you do that. But let's just run through a few here. So adding, basically, when you use a plus symbol with strings, it works as concatenation, concatenating the strings together. Some operators don't work. So like subtraction doesn't work. You can do addition, but you can't do subtraction with strings. But there are some surprising ones that do work. So multiplication, you can do that with strings. It'll actually just duplicate. It will duplicate the strings however many times you're multiplying it by. And you can also raise things to the power as well. So we have 8 civils and engineering here. 1, 2, 3, 4, 5, 6, 7, 8. It is also important to note that strings can be numbers. This is particularly important if you're parsing in files. It can be an easy mistake to forget to convert the numbers which appear as strings in the file. So here are some examples. And when you use operations on number strings, the operations perform in the same way as regulars. So that bottom one there is not equal to 15 because 5 is treated as a string. So it instead concatenates, it duplicates 5 and then adds another 5 to it. So you can do operations with booleans, but there aren't many you can do. You can use the not keyword to invert something, and addition. So we need to bear in mind that trues are stored as ones and falses are stored as zeros. So what Python's actually doing here is pretty much solving just 1 plus 0 is equal to 1, which is true. And then 2 falses, that's 0 plus 0 equals to false. True plus 2, 1 plus 1 equals to 2. And then true minus true, 1 minus 1 equals to 0. So, I mean, not all of these behave in super meaningful ways. Actually. Yeah. Okay, so you can also do comparison operations in Python. And any comparison will give a Boolean result, so either true or false. So 1 is greater than 0. Yes, that's true. 4 is less than 3.2? No, that's not true. And is 2 greater than or equal to 2? Yeah, that's true. So this is something that's quite important to remember, and it's an easy mistake to make when you're just getting into Python. You have to use if you are checking whether 2 things are equal to each other, not a single equals in Python is assignment, where you assign the value to something else. Double equals is what you're comparing 2 values. So as would be expected, 4 is not equal to 7. And here we have checking for not equality. So it's exclamation mark equals for equality. So, sorry, run the line, and we see that that's true because 4 does not equal to 7. Now, does 29 equal the string 29? No. They're very different. They're stored very differently in Python. So these operators can also be performed on strings. So now we come back to ASCII just for. So an A has an ASCII value of 97 and Z has an ASCII value of 122. So when it does this comparison, it substitutes the values in, and 122 is bigger than 97, so that will return false. So I'm just going to have a quick look at an ASCII table. So while that's loading, so if we move through the next line, if we were to sum the value of all letters here, we would have 97 plus 122 times by 2 on the left, and 122 plus 97 times by 2 on the right. So it looks like the right is a smaller value, but the comparison is done piecewise, just like alphabetical order. So the second term, ZAA, is greater than the first. Looking at the difference between lowercase and uppercase characters. So uppercase characters have a lower ASCII value than lowercase characters. It doesn't quite, just the way it was set up. So this statement is false. We see that strings cannot be compared with integers, even though strings are converted to integers when they're used in comparisons. So when we define a string, we have to use the same quotations at the start and the end of the string. Let's say you wanted to use single quotations, but you also wanted to put a comma somewhere in your string. This is not going to work. I'll show you what happens then. So it will treat that comma, treat that apostrophe as the end of the string. You need to use a different apostrophe, either single, a different quotation, either single or double, to use to identify the string for that to be ignored. So, and here's another example going the other way. So it can mean a number of things, including treat the next character literally. So let's say we wanted to use both types of quotations in our string. What we can do is we can backslash one of the quotations, and it will skip over the interpretation that's ending the string and just treat it literally as a single quotation. That allows us to use any kind of quotations within our string. When we run that, we see that the backslash actually disappears and the single quotations remains. So the backslash is very special to write, and if you want to write a backslash, you need to write 2 backslashes, because a single backslash is the escape character. So backslashes also have special characters. So the \n means a new line. So if I was to run this statement, you see it actually splits 2 lines into writing it on 2 separate lines. We have a \n and \t. So this is going to return a new line and then on the second line. So that's what the \t means, tab. And that's what we see here. Right, moving on to variables. Variables are used to store data types in computer memory. They can be later accessed by typing in the variable name. Variable names cannot have spaces. They must start with a character and can contain numeric characters. Variables not be words, so these are words that have a predefined special meaning. And you know if you typed in a keyword because it will render in color. Variable names should also be meaningful and describe the value being stored so that you can understand and make sense of your code more easily. It's common practice for variables to be lowercase with spaces replaced by underscores. So to assign a value to a variable, we use the single equals. This comes back to single versus double equals that I mentioned. You need a single equals for assignment. So let's create some variables. Number 1 is 7, number 2 is 3, text 1 is text. It's pretty straightforward. And we can retrieve the value of the variables by typing in their name. Number 1, we get an output of 7. Number 2, and then we're going to raise that to the second power. So 3 squared is 9. Here we get an exception, which is basically something went wrong. What we've done wrong here is we have written down a variable that we haven't defined previously. We can also overrule of a variable by assigning it to something new. So when you look at text1 and num1 again, we see that text1 is now new text and num1 is the original value, and then by 2, which was original number value was 7. You can also assign variables a new type, so a type that it wasn't beforehand, which you can't do in some other programming languages. This is an example of where Python is quite flexible, quite easy to program with because it doesn't have as many rules around forcing data types as some other languages. There's a shorthand way to change a variable's own value and assign it a new value. This works. This is done using the plus equals, for example. So now we've just increased number by 4 to 7.5. Use a minus equals to subtract. So that is subtracting 1.8 from the original value. We can use the multiply equals to multiply. And we can use the divide equals to divide. So all right, so here are some more types. For a matrix, you should use lists when the contents of the list may be modified. They're often referred for this reason. Tuples, they're very similar to lists, except you should not use them if you're going to modify the contents. They're called immutable for this reason. Generally, you want to use lists because you will want to edit data within them. We have dictionaries. Dictionaries have 2 parts. They have a key and a value. The key is basically a lookup for the value. And the key must be unique. And then we have sets, which acts like a mathematical set. It's a list that can contain duplicates and is unordered. So dictionaries are also unordered as well. In list tuples, dictionaries, and sets, items within the collection are separated by commas. You can use a mixture of data types within these. And that's another example of where Python is more flexible than a lot of other programming languages that enforce types be the same in these data types. So let's have a look at strings again. So here, we're redefining the text1 variable. When we use square brackets and insert an integer, we are basically indexing the variable. What that is doing is retrieving the character that sits in the 0th position of the string. So it's important to note that Python indexes from 0, not 1. So most languages index from 0, but MATLAB is a notable exception that indexes from 1. So here, the very first element is a y. Then we get the second element, and third element, and the fourth element. Looks like nothing was returned for the fourth element, but there is actually a space there. You can also index from the back of the string using negative numbers. So -1 is the last element, and -6 is the 6th last element. So 1, 2, 3, 4, 5, 6, the S. Slicing is similar to indexing, except it's where you want to retrieve multiple characters. It's inclusive of the first index, but it's exclusive of the last index. So here we are getting characters 4 to 6. That's exclusive of 6, so that's characters 4 and 5. So 0, 1, 2, 3, and then 4 and 5 is the C and the A. Here we are doing slicing from the back of the string. Notice that the first number is still smaller than the last number. And we get everything up to, but not including the last, get the last 5 elements, but not including the last element. So you can leave out either the first or the last character in the slice. So here we're leaving out the first character, and what that will do is Python will start the slice from the very start of the string. So start of the string up to the 8th character at the 8th index. And then this is similar, except we are coming from the back of the string. If you just use the colon itself, then you're not specifying a start or an end position, and you'll get the whole string back. Rather than slicing sequentially, we can skip over elements by adding a third parameter, which is the number of elements you're going to skip over. So here, this is getting every second character up to and not including the 24th character. This one here is getting every character in the string, but stepping in increments of 5. And then similarly to the first one, except we're just moving backwards through the string from the 24th character. So the index you use must be an integer that's smaller in absolute value than the length of the data that you're indexing. So this data has 0, 1, 2, 3. So the highest index is 3 if you're indexing from the front. So when we try to get the fourth element, it does not exist, and we get an exception. So list. So lists are created using square brackets, where every character is separated by a comma. The data stored within the list can be any kind of type, and you are also allowed to mix type. So here we have floats, integers, and strings. Lists can be empty, so you can do that either just using square brackets with nothing in them, or you can call the word list with circular brackets. And you see that the result of both of these is the same. Lists can also have lists of lists as well. So think of this like a multi-dimensional array. Indexing and slicing applies to lists in this very similar way that it applies to in strings. So square brackets, and the number you put in is the position of the element you want to retrieve. So getting the first element from random, which next, and the following element, 3 and man. And then finally, if we try to get the index of an empty list, it's not going to be able to, that's going to throw an exception. So multidimensional lists can also be indexed by adding a second set of square brackets. Basically, each set of square brackets is indexing a dimension deeper into the list. So the 0th element, which is 6 and 2, and then the 0th element in that, which is a 6. That's what we're indexing here. This one here, getting the second element, well, third element in the list, and the second part of the index, that, and we're getting both values, just the colon. You can't use a comma to separate the indexes in dimensions for lists, but you can do this in some other common data types like NumPy arrays, which I won't cover in this course. So I forgot to define these as strings. So now we're moving on to tuples. Tuples are defined similarly to lists, except you use curved brackets. Once again, you can use multiple data types within a tuple, and tuples can be empty, which you can use either just regular curved brackets, or you can use a keyword tuple for that. You can also have tuples of tuples, just like lists of lists. Now, let's create this here is a tuple that combines lists, elements of lists and tuples. So we get, once again, we're mixing data types, which can be done in Python, but not a lot of other programming languages. So when you see that, we get elements from the array, 6 and 2 and -1, and then greetings. Notice that this whole thing is the element in position 1. So the whole thing, all 3 words are being inputted into the random tuple. Once again, indexing and slicing works very similar. So firstly, we're getting the very first element in the coords, which is the x here. And we're looking at values tuple and getting the second and third elements, which is the 9.5 and -2. And then finally, once again, you cannot get an index of anything in an empty tuple. The final example shows another is also multidimensional, a multidimensional index for the random array, random tuple, which will return this element. Here's the first element, and then 0, 0 would be hi. Oh, hi and hello, rather. So let's look at another data type, dictionaries. It's a very simple dictionary here with just one element. So when we define a dictionary, we need to define a key and a value. The key is separated from the value. Well, the value is assigned to the key using a colon, and elements are separated using commas, just like for lists and tuples. So here's another example of some stock. This one here, we've defined the same key twice. So dictionaries don't like this. They can only, the key must be unique. When we do this, it will actually update the key to the very latest value. So this one here is fruit 6. So when I print that line, we'll see fruit 6 is returned. So once again, dictionaries can be combined data types. You can initialize empty dictionaries using the curly brackets or using the dictionary keyword, keyword rather. Both of those are empty dictionaries. We can have a dictionary of dictionaries. Notice here that you must always have a key. So I need this 2 here, basically. Otherwise, it will just see, because it treats the curly bracket part as a value, in this case, the inner curly brackets as a value. And without a key, we get an error. So, or exception, something like this. And dictionaries can also combine other iterable data types as well, like lists. When getting elements from a dictionary, you cannot use the same indexing as for lists and tuples. So let's have a look here. So we're actually specifying a string here. So this is not, we're not specifying the position of the key. We have to specify the key's name itself, because dictionaries are stored without an order. So if you were to put a key in, it's meaningless. If you put a number in, it's meaningless, rather. So we're looking at the collection variable and the results key. When we get that, we will get a list returned. Then we are getting the element in index position 1, which is the second element, 2.8. That's what's returned here. Template And now here, template 1, 1. So because template 1 is defined where the keys are actually integers, we do use an integer to get the value, but that's only because we have that condition. All right, let's have a look at functions now. So you can get a lot more functionality out of these data types when you look at the functions that are built into these. The syntax for accessing, so we also have properties. So data types like these also have properties, and the way that you would get a property from some data is you write the data name and then dot the property that you want to retrieve. The dot signifies that you are accessing the property. You'll always have something returned when you do this. So the syntax for using a function is data dot the function name, and then you have to use curved brackets, and inside the curved brackets you specify any optional arguments. Note that not all functions need to have the data bit first, so can be left off if it's a function that's not associated with a specific type and Python is aware of this function. Notice you must have the curved brackets after the function name, otherwise Python will think you're accessing a property. When it comes to arguments for functions, they have to be comma separated, just like in lists, tuples, and in dictionaries. It's important, not all functions return a value, like for properties. Some functions will change your data internally without returning a result. Users can also create functions too, so let's just do that now to see how they work. Every function has to start with the keyword def, and then a name that's unique to the file. After the name, you must have our curved brackets again, and inside these, you can put any kind of additional arguments that may be required. For example, on the lines that follow the function, that is the body, Python, all you need to do is just indent and Python will know that every indented line belongs to that function. You don't need to write end after the function like in some programming languages like MATLAB. So if I was to run these two lines, we see that we have no output. To run a function, you have to explicitly call it. What I was doing there, what I've only done there is defined the function. So now when I call the function, it runs and the print hello world is returned. Now functions, let's have a look at functions with an argument. So here I just defined the function, and now I'm going to run the function with the argument CESA, and that is going to print to the terminal. Another function here which builds a list. Oops, these two lines. So now let's call this function with the values 7, 8, and 9. What we see is the square brackets, which indicate that this is a list, and then 7, 8, 9, exactly in the order that we were expecting. So it looks like these three functions are actually returning values, but in actual fact, they are not. What's happening is the print statement internally prints the console, but doesn't actually return a specific value. One way that we can check that is assigning the output of these functions to a variable. When we do that, we see that the output from function 1 is none. So in order to create a function that actually returns something, we need to use the return keyword. So here we're going to return a tuple. So now when we assign output to the result of this function and then print it, we see that there is a value returned. That is as we were expecting, 27, 153, and 13 as a tuple. Now let's have a look at some built-in functions to the types that we looked at earlier. So we're going to define a new variable, num1, and now we're going to use the append function. This is a function associated with lists. What it does is it will add -1 to the end of the list. Sorry, I need to run the line. And here we go. We see 672 and then -1 has been added to the end of the list. If you wish to add multiple elements to the end of a list, you can use the extend keyword, and the argument that you have to put in there is something that is iterable. So that has to be a list or a set or a dictionary. Actually, those won't work, but it has to have comma separated values, basically. So when we see the output of that, we see that 0.8, 3.1, and 7.45 have been added to the end of the variable num1. We can use the sort function to sort the contents. Notice that nothing is actually returned from this function. What it does is update the list internally. And here we see the updated list from -1 up to 7.45. We can use the pop command in order to remove and return a value. So because we are removing and returning, if we assign a variable to the output, that value from the variable from the original list will be assigned to the output. So here we're getting the element in the index position of 2, which is 0, 1, 2. So that's a 2, and that is what's printed as the output. It's quite difficult to know what method to use, and there are plenty of methods for every function, for every data type. A good initial way to have an investigation to see what's available is to use the dir function. Now, notice that there's no data type specified in front of that, and that's because this particular function is not associated with the data type, and it's loaded in automatically by Python when you create a script. So this will connect up to the correct function. So when you do that with lists, we see a whole heap of different functions here. Basically ignore everything with a double underscore, and we see the main functions. We have append, clear, copy, count, extend, and so on. Then we can do the same with dictionaries. If you want to find more information about these functions, if your IDE has good support, you can use that to search up more information about them. Otherwise, you can go online and have a look. So here is just generic data structures in Python. So lists, we have list.append, which we used, add an item to the end of the list, .extend, extend the list by appending a series of items. insert an item at a given position, remove an item, and so on and so forth. There's plenty of information here. We've also got information for tuples. We've got information for dictionaries as well. So the online documentation is a really good resource, but sometimes it can be confusing. And in that case, it's probably best just to Google search exactly what kind of problem you want resolved. All right, so now let's have a look at some dictionary methods. Actually, let's go back to the website. If we look at dictionaries, you want to look at get. Oh, looks like I can't find it here. I'll just go back to Python. So dictionary.get, basically what this does, similar to, it gets the value associated with the key. And it behaves very similarly to just, oops, I have to reinitialize the variable. Now we were down. Oh, geez. Here we go. We're down here. So when we use the get method, we get the value associated with the key, which in this case is 12. Now, it may seem exactly the same to using the square brackets to get the key, but the difference is that when you use square brackets and on a key that doesn't exist, you'll have a failure, an exception basically, in a program. But if you use the get keyword on a key that doesn't exist, it will. So let's have a look at the keys method now. So what we see here is we have a special data type that's returned called dictionary_keys. And we see the 3 keys that were in our dictionary: milk, sanitizer, and toilet paper. Now, let's get all the items using the items method. So this returns, again, a bit of a very interesting data type. Looks like a combination of a list and tuples. But what you see here is all of the keys and the associated values inside each tuple. Now, another method which takes an argument, which actually has to be some kind of dictionary iterable. We are going to update the dictionary, the toilet paper keyword, with the value of 10. So since toilet paper already exists in the dictionary, it will find that and then update the value to 10. Yeah. I think that's all I've got time for. Yeah, thanks for tuning in. And just a final information at the bottom here. The best way to improve your programming skills is to practice. Have a play around with this script, change numbers and functions, see what happens. And further general learning, I strongly recommend using LinkedIn Learning or lynda.com. There are plenty of tutorials there, really well structured for Python and other programming languages as well. And for specific questions, I recommend Static Change and Geeks for Geeks. as these are great resources.